For our next example, we're going to do page 8 from your guided examples for hypothesis testing packet. It's another example where sigma is known. And when sigma is known, we do a z-test. The Environmental Protection Agency has been studying Miller Creek regarding ammonia nitrogen concentration. For many years, the concentration has been 2.3 milligrams per liter. However, a new golf course and new housing developments are raising concern that the concentration may have changed because of lawn fertilizer. A change, either an increase or decrease of the ammonia nitrogen concentration, can affect the plant and animal life around the creek. Let X be a random variable representing ammonia nitrogen concentration in milligrams per liter. Based on recent studies of Miller Creek, we may assume that X has a normal distribution with sigma equal to 0.3. Recently, a random sample of 8 water tests from the creek gave the following X values: 2.1, 2.5, 2.2, 2.8, 3.0, 2.2, 2.4, and 2.9. The sample mean for this data is X bar is 2.51. Let's construct a statistical test to determine the claim that the concentration of ammonia nitrogen has changed from 2.3 milligrams per liter. We're going to use the significance level of 0.01. You can see to the left of my problem, I've written the important information. This is a great habit to get into. We know that sigma is known, so we'll be using a z-test, and we'll be using our calculator skills for this. We have sigma is 0.3, mu is 2.3, x bar is 2.51, and n equals 8. Let's write our claim. So it says the claim is, we're testing the claim that the concentration of ammonia nitrogen has changed from 2.3 milligrams per liter. So we're testing the claim that the mean is not equal to 2.3. Our null hypothesis always has an equal to sign, so we'll say mu equals 2.3. And since our claim does not include equality, because not equal to is not equality, right? We can say our alternative hypothesis is the same as the claim. So our alternative hypothesis is mu is not equal to 2.3. So we can expect a two-tailed test here. And we know that alpha equals 0.01 because it's given to us at the very end of the prompt. Now let's put this into our calculator to do the hypothesis test, find our test statistic and p-value, and decide whether we're going to reject or fail to reject. You're going to press stat and go over to tests. The z-test is the first option, and we're using stats even though they gave us all of the data there. Since the summary is below it, we don't need to type the data into our calculator. The mean of this data was 2.3. Standard deviation is 0.3. X bar for this was 2.51. And we had 8 data values, so that's our n. And you're always going to look at what your alternative hypothesis was for a symbol, and we had not equal to. So we can go ahead and we can calculate or draw. I usually choose draw so I can see the picture and make sure it makes sense. You can see our test statistic is z equals 1.9799, and our p-value is 0.0477. You can see I've written the information we got from our calculator. Now the p-value, 0.0477, that's split between our two tails. So actually in this tail here on the right, we have 0.0477 divided by 2. It's about 0.024. But we also have that amount in this tail, 0.0477 over 2. So our area is split between our two tails. Now, to reject or fail to reject, you can either choose critical value method or you can choose p-value method. Either one is fine. I'm going to use p-value method. And our p-value is 0.0477. And for alpha, we used a 0.01 significance level. So we need to compare which number is bigger. And 0.0477 is bigger. And if the null is, or if p is high, the null will fly. So that means we're going to fail to reject this. Let's use our flowchart to write our conclusion. And it says, does the original claim contain the condition of equality? Remember, our original claim had a not equal to sign. So that would be no equality. Did we reject? No, we failed to reject. So we should say there's not sufficient evidence to support our claim. In conclusion, there is not sufficient evidence to support the claim that the concentration of ammonia and nitrogen has changed from 2.3 milligrams per liter. Tune in to the next video to go over the rest of the examples in this packet.